Hello, class. This is Mr. Sutton. I hope you had a safe and relaxing spring break. Back with another lesson. This is skill 22. We're going to be talking about samples and data today. First, we have some definitions. Population is the entire group that is being studied. A sample is a subset of the population or a smaller portion of the population. So we are going to obtain information about the sample and use it to predict information about the entire population, because the population generally is going to be something too large for us to get information for the whole population. So we want to just take a sample of that and use it to predict information about the whole population. We're going to be doing this by drawing inferences from tables. So this is the survey results from a sample are used to predict the population, but do not exactly represent the population. And then it says inferences. A random sample gives a conclusion about the population. So if we're taking an inference, then we are using our sample to draw a conclusion about the population. So let's look at this first example here. A fitness center took a random sample of 40 of its members, so these are the 40 members here in the table, and surveyed them to see how many times they plan to visit next week. Fitness center results are shown. So like this person said they plan to visit 0 times next week. This person said they plan to visit 2 times next week. Right, and this is all 40 responses represented in this table. And then down here it says which is the best estimate for the mean, which is the average, number of times members of the fitness center plan to visit next week. So if we want to find the mean or the average of this table, we would just need to add up all of the results here and divide that by the number of people, which is 40. So take a second, pause the video, and add up all of these numbers and see what you get. So I added up all of the columns here individually first, and then I took those numbers and added those together. I got 52 total visits out of this sample for next week. So now we want to take that 52 and divide it by 40 and see what we get. And now I got exactly 1.3 as the decimal there. So that is going to be answer B. Right? So from this sample, we can infer that there is about 1.3 visits per person next week. So let's go ahead and take a look at the second example on the next page of the notes. It says an amusement park took a random sample of 50 of its visitors and surveyed them to see how many water rides they had gone on so far. The amusement park's results are shown. So these are the 50 people. Okay, and this is their response in the box. So this person had only gone on 1 water ride. This person had gone on 0. This person had gone on 0. This person had gone on 1, so on and so forth. Which is the best estimate for the mean number of water rides visitors to the amusement park have gone on so far? So again, for this one, we will need to add up all of the data from the sample we're given, and then we'll need to divide that by the size of the sample we're given. So I did the same thing here to add up all of the number of visits. I first added up each column individually. And then I added all of those numbers together, and I got 40 total water rides from this sample. So next we want to take that 40 and divide that by 50, because there is 50 people in this sample size. And I got exactly 0.8 when I did that. So that would be answer B. So again, the question is, which is the best estimate for the mean number of water rides visitors to the amusement park have gone on so far? So that answer is not necessarily 0.8. We don't know for a fact that the average number of water rides visitors have gone on is zero point 0.8 because we're not looking at the entire population. We're just looking at this sample. So this is our best estimate. Based off of this sample, we can assume that all visitors have gone on an average of zero point 0.8, but we don't necessarily know that for sure. Okay. Last thing we're going to do here is we're going to look at this U-try here. So this says 12 students were asked how long they spend on math homework. The data is given in minutes in the table below. What is the best estimate for how long the average student spends on math homework based on this sample? So this is just 12 students that were asked, but we are trying to infer based on this data what your average student in school spends on this data, on math homework. So go ahead and try this one on your own, and then I will put the answer up in a moment. Go ahead and pause the video and try this one on your own. And this is what I got for my answer. Once again, I added up the total minutes that we have from the sample. I got 445 minutes, and then divided that by the size of the sample, which is 12 students. This time I did not get an exact answer. I got 37.083 repeating, so I approximated that. That's approximately 37.08. I'm rounding to the nearest two decimal places here, minutes per student. Okay. If you have any questions about this lesson or on the homework, please come to mine or Miss Parsons' office hours, and have a good day.